Let's see here. The domain of a function. That's the real numbers you can plug in here where you get a real number out. So things you don't want to do is take the square root of a negative or divide by 0. Because if you do this, you end up with the imaginary number out. If you do this, the function chokes. So we have two constraints here. That square root, we need to make sure the stuff inside is bigger than or equal to 0. That's constraint number 1. And number 2, we have to make sure this stuff on the bottom is not 0. Other than that, any real number is fine. So this guy says x has to be bigger than adding 4 to both sides. Let's give us a little number line here to help us out. Put 0. So 4. Since we can do equal to, let's use a different color here. That constraint says anything over here is fine, but what about this one? When it's not 0, let's find out when it is. That guy can be factored like this. X minus 5 times x plus 5. Okay. Let's just go ahead. When is it equal to 0? It's equal to 0 whenever x is positive or negative 5. So those are the numbers you cannot plug in. So let's see. Can't be those. Well, here's minus 5. Don't have to worry about it. But over here is positive 5. We have to exclude that one. So let's go ahead and put round parentheses like this and like this. So you can have anything from 4 up to 5. Don't include 5. And anything from 5 up to infinity. And then bust a red box around our answer there. Now, as far as this paper, yeah, it looks good. Ta-da. Okay. Oh, and he wrote his answer up here. How nice. Let's look at the next one. Number 2. Here's our difference quotient. This is just the slope formula. And here's our function. Okay, well, what is all this? Come on, y'all. Equal sign. Like, what is the, oops. There. Okay. Pen, there. Like, what is this? We need some equals. We need the is. What is this? So, this guy. Oh, come on now. Where's my pen? Pen. Okay. This equals. Well, if this is f of x, what is f of x plus h? Well, replace x with x plus h, and it says square the input, so there you go. And we got a minus sign, all right, and then f of x. There's f of x. It's a number. You want to subtract the whole number, so you better put parentheses. Just like if you want to subtract 3, that's the same as subtracting 1 and 2. You need to subtract the whole number. All right, that's the top. Now the bottom, h. So what do they have over here? Like, where the hell did this come from? No clue. I don't know what you are. Huh? I don't know. Anyhow, equals, right? This is a number. No matter what x or h is, this will equal, let's square this dude. You're going to get an x squared. You will get your h squared. guess what? You're also getting an x times h and an h times x. So you get twice xh. And now, don't forget your minus 2. Minus 2. Minus x squared and a minus minus plus 2. So minus x squared plus 2. All right. Here, I forgot I can just do this. Nice. All over h. Cool. Okay. So what is that? Well, let's see. We can do minus x squared plus x squared is 0, plus 2 minus 2 is 0. We are left with 2xh and an h. Oh, that's kind of ugly. Xh plus h squared over h. Now, don't be doing nothing silly like that. No, no, no. What can we do here? What is this? No idea. All right. What we can do, I'm going to go over here. Equals, factor an h out of the top. 2x plus h. Okay. This is h over h. Right? No matter what h is, that's just the number 1. You can choose not to multiply by it. So we got a 2x plus h, and that should be your final answer. See, what did he do here? I have no idea what any of this is. You have to write complete sentences, dude. Huh? Come on. All right. There you go. And, all right, what is this? Sine is equal to that. Okay. Theta is in quadrant 3. 1, 2, 3. So the angle's over here somewhere. All right. Evaluate secant. Okay. Well, there's lots of different ways we could do this. We could use identities. Using sine, we could get cosine. Cosine's 1 over secant, right? So let's, oh, can I do this? Boop, boop, boop. Whoop. Cool. All right. Secant is 1 over cosine. All right, so we know from the Pythagorean theorem, cosine squared plus sine squared is always 1. So cosine squared is 1 minus sine squared, right? So that means cosine squared is always 1 minus sine squared, which in this case is 1 minus negative 1 over the square root of 17 squared. A minus times a minus is a plus. Root 17 times root 17 is that. And this 1 here is the same thing as 17 over 17. 17 minus 1 is 16. 16/17, that's cosine squared. Therefore, cosine is square root of 16 and the square root of 17, but is it plus or minus? Well, if the angle is over here, cosine has to be negative, so let's put that minus in there. All right, so if that's cosine, then secant, which is 1 over cosine, is negative 4 over the square root of 17. I'm going to go ahead and say equals secant again, just so that I can put a nice box right here. Let's make sure this is not a 0. There we go. Oh, and there's something with these math ed people. They don't like the square root being on the bottom. So let's do this. Well, oh well. Come back. Oh man. Undo. Yay. Alright. Let's put you back where you go. Yay. And let's move you over here. And oh, come on. Undo. Yay. Take this right here. We're going to delete. Alright. What you can do. Oh well. That's alright. I'll fix it. Alright. You can multiply by this by number 1 if you want. They call this rationalizing the denominator. They don't like an irrational number on the bottom for no reason at all. Okay, this is just multiplying by the number 1, so it's still equal. What that does is it gets rid of that square root off the bottom. But now you have a whole bunch of extra pen strokes, which I don't think is cool at all. Let's see. I don't know. There we go. And let's box the answer. Actually, I'm going to go ahead and put this again at the end so I can box my answer nicely. Alright, now that's 3 over. Okay, we got a ladder here. It's leaning up against a building. Boop. 24 feet, good. And there's an angle between the ground and the ladder. Alright, 85. Whatever. How high does the ladder reach up the side of the building? Alright, we'll call that H for height. I'll call this theta for my angle. And I'll call this L for ladder, just for fun. Now, right angle. So we need a relationship between an angle, its opposite side, and the hypotenuse. Excuse me. Sounds like a job for me for sine. Oops. There we go. Well, I know that sine of an angle is opposite over hypotenuse. Okay. And what do we need? This would be H. H, and then I called this hypotenuse, I called it L, right? We're solving for H, right? So, therefore, H is multiply both sides by L. L sine of theta. And here, for this particular problem, L is 24, and theta is 85 degrees. And this is what H is. Boop. Yeah, you might not like that, but I'm totally fine with that. That's a great number. Oh, they want us to, like, convert it to a decimal. Boo. Do I have a calculator somewhere? Nope. Wait, what? What's that? Whoa. Okay. Where's the calculator? Magnifier? No. Ooh, here we go. Calc. Oops. Calculator. Boop. Oh, well, I guess I'm in the wrong spot. Alright. Uh-oh. There has to be a way to do a calculator. Ooh, I bet this thing does it. How do I do a calculator in Notability?